Hello children, welcome to AIMS India's online classes. In today's video, from physics subject, force and laws of motion topic we are going to continue. So our today's concept is regarding inertia children, regarding inertia. So we are going to learn about concept of inertia. So we all know that when a stationary object remain wherever they are placed. So the objects, they will remain there only wherever they are placed. So they cannot move from one place to another place on their own. Suppose if I keep one book on a table, if I keep one small book on a table, the book will be there only on the table. It cannot move from here to here by its own without any external force. So it cannot move unless and until we use a force. So they cannot move on their own from one place to another place unless forced to change their state of rest. When they are placed, they will be in the state of rest. To change the state of rest, we have to apply some force, then only they will move. Otherwise, they will continue to be stationary or continue to be at the state of rest in the same place. So that ability of staying in rest, staying in the same position without moving is called inertia. Or similarly, an object moving with constant velocity. Suppose one object, it is one ball, it is moving with the constant velocity 10 meter per second. So how long will it move? If it is moving in the air, if there is no air drag, or if there is no friction of air, or if there is no opposition to the motion of ball because of air, it will be moving with 10 meter per second. Or if it is moving on the earth friction tries to stop it. If there is no friction, if there is zero friction, so practically it is not possible, but if there is zero friction, then it won't stop at all. It will be moving with 10 meter per second velocity continuously without stopping. With constant velocity it will be moving. Means it will be continuing its state of motion without any change. So that is also called as inertia. Means being in the same state. Either it may be rest or it may be motion. Being in the same state is called inertia. To stop its motion, we have to apply force. To make it move from rest position, we have to apply some force. If you apply some force, the body which is in rest, it will start moving, or which is already in motion will come to rest because of the force. So the property of an object by which it resists a change in its state of rest or state of uniform motion in a straight line is called inertia. Means it tries to stay in the same state of rest or same state of motion. That property is called inertia. Or if we try to apply some force, initially up to some extent it tries to resist that force. If there is a stone, huge stone, if you apply force, immediately it won't move because it will try to show resistance to our force. But if our force is strong enough, then only it will be able to change this inertia, and it will be able to move the stone. So the resistance shown by any body or any object to change its state of rest or state of motion is called inertia. So mass is the measure of inertia. Inertia mainly depends on mass. Heavier masses bodies like elephant, the elephant will be having more inertia compared to a small ant, because mass is the measure of inertia. If the mass is more, inertia will be more. More force to be applied to change its state. Or if the mass is small, inertia will be small. Less force to be applied to change its state of rest or motion. So here children, mass of a body is the measure of its inertia. Inertia is a fantastic property, or sometimes it is called as intrinsic property. Means the object by itself, it possesses that property, like our human body genes. So it's an intrinsic property. If it were not present, your books or class notes could mingle with those of your younger brother or sister. The books which are kept in your bag will be there only. They will not be moving to anywhere. Suppose in the beside your somebody's bag is there. This book will not go to that bag. Why? Means because of inertia property. Or your wardrobe, your birwa with full of clothes could move to your friend's house, creating chaos in the life. Like that, if the object starts moving, everything will be miserable. Everything will be miserable. If you keep an object in one place, it will go to some other place. If you buy a new TV and we kept in our house, it went to some other house, we will be crying. Like, if it happens like that, we will be crying. So it won't happen like that because of inertia. One minute, children. Here, children, the state of rest or uniform motion of an object, they are not absolute. They are not absolute. Means the rest or uniform motion, that depends on the observer. They will change from person to person. They will change from person to person. So they are relative terms. They are relative terms. Means the object which is at rest with respect to one observer may appear to be in motion with respect to some other observer. Some other observer. Suppose you are sitting in a classroom. You are sitting in a classroom. You are sitting in a classroom. So according to the friend sitting in the same classroom, according to him, you may be at rest. But if the same boy observed from another planet which is outside the earth, according to that planet, or according to that boy who is in the outer space, according to him, the earth will be moving and your place will be moving. Your classroom will be moving, your table will be moving, and you will be moving. So according to the person who is in outer space, according to him, you will be in motion. But according to friend, your friend sitting in the same classroom, you will be under rest. So the same object only, according to one observer, it is under rest. According to another observer, it is under motion. So that's why the rest or motion depends on observer. So that's why they are not absolute terms. They are called relative terms. Means they will be related to the observer. They will be related to the observer. Or let me take another example. So while you might have observed, all of you might have observed this example. So when you are traveling in the train, so you observe that the trees and the trees, poles and other objects appears that they will be moving. Appears that they will be moving. So for a person inside the train, the outside objects appears to be moving. Appears to be moving. But the person who is standing on the earth, for him the two objects which are on the earth will be under rest. So the rest and motion are relative terms. Relative terms. They are not absolute terms. Next. So the change in velocity of an object can only be brought if a net force acts on it. Net force acts on it. Means whenever we tell about there is some change, that change will happen not only because of force. Suppose in the game of tug of war, you might have observed. So some persons will be pulling the rope this side, and some persons will be pulling the rope this side. If they use same force, F1 in this direction, F2 in this direction, so until and unless when the forces are equal, there will be no change in their position. Nobody will win. But when this force F1 force is more, so then only rope will come this side. All these people will cross this line, and these people will win. So if both forces are equal and opposite, they are applying 10 Newton force towards east direction. They are applying 10 Newton force towards west direction. What is the total force applied? Force is a vector quantity. So its direction, if eastwards, if we take as plus 10, positive direction, plus 10 Newtons, then the force acting in west direction will be negative. If one is plus 10, another will be minus 10. So what is the total force? 0 Newtons. So that's why nobody is moving. Nobody is crossing the line. The rope is like that only. The players are like that only. Why? Because they are applying the same force in opposite direction. Because of that, the total net force, resultant force is 0. That's why no change we are able to observe. But once on one side the force is more, 12 Newtons, other side 10 Newtons, then what happens? 12 Newtons minus 10 Newtons, 2 Newtons. So right side, 2 Newton force is more. So these people will be pulled towards right side with the 2 Newtons net force, and they will cross the line, and these persons will win the game. Like that. So we can observe the change in velocity only when there is net force. Otherwise, we cannot observe the change in velocity, though the force is acting on it. That we have to keep in mind. So, and the little car has less inertia than big truck. Already we have told inertia depends on mass. Inertia depends on mass. If you compare one truck and one car, truck will be having more inertia due to its more mass. Car will be having less inertia compared to truck because of its less mass. Next, concept of force. So already we have learned, children. In our previous videos, already concept of force we have discussed. So push or pull is called force. So force comes into play because of interaction. It can change state of rest, state of motion of body. It can change shape, size, shape of the body. It can change direction of the body. So now force and motion. How force and motion are related. So here force is a vector quantity. So when several forces act on a body simultaneously, we have to calculate net force. We have to calculate net equivalent force by using the laws of vector addition. If on the same body, F1, F2, F3, F4, like that, if so many forces act on the same body, we have to add F1, F2, F3, F4, all forces using the laws of vector addition. Why? Because force is a vector. Normal addition we cannot do. Vector addition only we have to do, and we have to find net equivalent force. That net equivalent force acts on the object. So again, motion of the body is characterized by its displacement, velocity, etc. So the motion, if you want to tell the motion of the body, we have to know its displacement, velocity, then only we can express some characteristics of motion of a body. So we will come across many situations where velocity of an object increase, decrease. Velocity fluctuations we can observe in so many objects. So in the case of freely falling body, when it is falling towards the earth acceleration due to gravity, G, because of gravitational force, will also be acting downwards. Because of that, the body velocity will increases continuously while it is reaching to the earth. So this is an example of velocity increasing. So this is an example of increase of velocity in a body. So the body is freely falling body. So in the case of ball rolling on a horizontal surface, if it is rolling, due to friction of earth, its velocity will slowly decreases and finally becomes zero. So like that, in our real life, in so many objects, the velocity may be decreasing, the velocity may be increasing, the velocity sometimes it becomes zero. So, and one more thing, a net non-zero force is required to change the state of a body. That also we have learned. So, for a body in motion, velocity will be changing. Why velocity will be changing? Depending on the direction of force acting on it. So, the motion and force are interrelated to each other, because motion depends on characteristics like displacement, velocity, acceleration, and so many things, which are controlled by force acting on the body. So that's why force and motion are interlinked to each other. Suppose this person is carrying the sofa towards right side with 20 Newton force. He is pulling the sofa. So whereas this person, back person, is pushing the sofa forward with 25 Newtons force. As both forces acting in the same direction, so net force will be 25 plus 20, 45 Newtons towards the right side. So that's why sofa is moving. So based on this basing on this force and motion, we have some laws proposed by Newton's theorem. They are called Newton's laws of motion. So we have about Newton's first law. After that we have Newton's first law, which is mainly based on inertia, and we have inertia in types of inertia: inertia of rest, inertia of motion, inertia of direction. Next, we will be having linear momentum. Based on that, Newton's second law is proposed. And we have weight, impulse, and Newton's third law, which is based on action-reaction, and some limitations of Newton's laws of motion. These are all we will be learning in our next video, children. So Thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website, children, aimstoday.in, for information regarding online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.